welcome to another class of physics. I'm Sumit Bhatnagar. I'm from Prepaze. So before starting session, we'll just explain you briefly what is Prepaze and why you should join it. So Prepaze is an online platform which aims to deliver knowledge to students from all over the world at the comfort of their home. We have dedicated and enthusiastic teachers from all over the world which will help you achieve goal. So please do check their website and try to book a demo class as soon as possible. Let's start today's session. This is the fourth session in series of the kinematics. All right. So last class basically we discussed a lot of questions for the kinematics part, the equations of motions and the average velocities and the average speed. We discussed a different type of questions. So in today's session we will be discussing the graphs of equations of motion. So this is basically a part of kinematics only. So today we'll be discussing graphs of graphical representation of motion. Graphical representation of motion. Now we discussed a lot of different things where we are discussing motions by the equations. Now graphs are also quite popularly asked. A lot of questions can be asked from this topic alone. So let us try to understand what different type of graphs can be done. So first graph is basically the displacement time graph we have. So basically the first type of graphs in this category are the linear graphs. Linear graphs. Okay, linear graphs means that firstly the displacement time graph is something like displacement time or xt graph looks like something like this. Okay, this is the first type. Let's say like that, the straight line. If you have attended my previous session, I told you this type of graph of displacement time is basically what? It's a uniform motion graph. That is, the velocity is constant in this case. Such type of motion, the velocity is constant. How do we know the velocity is constant? But because what is velocity? It is change in the position, that is change in the x over delta t. We can see that it's a straight line graph. So there's an equal change in delta x over equal change in time. That's why it's a constant. All right. So the velocity is constant. So how will your VT graph look like? The VT graph for this will be a line which is something like this, a linear line. Right. In this category, now there is another type of graph we have. So another category of graph in this is basically a graph which looks like this. So this is the second category, which is straight line graph again, but it's like this. What is happening in this category? In this basically the green line which I've drawn, the particle is traveling in the negative direction. How to know whenever the particle is traveling in a positive and a negative direction from a graph? See. Consider origin. So this is a like for all the graphs which you encounter for the displacement time, it will help you out in this. Consider the origin over here like this. This is the origin, suppose. Now if a particle is going away from the origin, that means it is traveling in a positive direction. In the red graph you can see that this is the origin. The particle is going away from that. That is basically in the x direction. It is going away. If the particle is coming towards the origin, that means it's going in the negative direction. You see the green graph, basically. Initially, there is some value of x, but as the time goes on, the x becomes what? 0. That means the particle has traveled in the negative, towards the origin or towards the negative direction. If the particle is traveling in the negative direction, how does VT graph look like? The VT graph of it will be this thing. I've drawn below the x, below the time, because it is showing it is a negative velocity, negative direction. For these graphs, how will an acceleration time graph look like? So if I want to draw an acceleration time graph, now obviously the velocity is constant. So what is the acceleration? Acceleration is just 0. So if I say what is the acceleration? Acceleration is just 0. That means there is nothing you can do for this. It's just a line which is basically overlapping the x-axis. Or you can simply write a equals to 0. For the second case also the acceleration is just 0. Right, that is basically the linear graphs we have. The next category in this is the non-linear graphs. Non-linear graphs. What are different kinds of non-linear graphs we have? First is to look like something like this. For your level, you can expect a graph which is a quadratic if you have a bit of knowledge of mathematics. So this is a quadratic graph basically. We say. That means S is directly proportional to t square. Okay, it's a quadratic graph. So it's look like that. See what is happening in the VT graph. If I want to draw a VT graph of this corresponding ST graph, how it will look like? I want to draw a velocity time graph. Now what is velocity? If you remember the previous classes, what is velocity? It is basically given by the slope of ST graph or XT graph. You can write S or X slope of the xt graph. That means if I want to draw the slopes over here for this graph, I will draw like this. So suppose this is the point, this is slope. At this point, the slope is this. At this point, the slope is this. It's keep on increasing, right? This slope is giving us what? The velocity. You can see from the graph the slope is continuously increasing. That means the velocity is increasing. Since the nature of the graph is s proportional to t square, that means velocity, which is delta s by delta t, will be proportional to 2t. That is that basically comes from the differentiation. Right now, if you don't remember it, it's okay. So if it is t square, the velocity will be in proportional to t. If the displacement was something like this, proportional to t cube, the velocity will be proportional to t square. So that is the nature basically goes on, and acceleration will be proportional to t. Okay, so similarly, if s is proportional to t square, velocity is proportional to t, acceleration in this case will be proportional to what? A constant volume. Okay, suppose it's 2 only, like this. Okay, so this acceleration is constant. Clear? So that is the category we will be discussing right now. So this is one of the type of graph which has shown. How the velocity time graph of it will look like. If I want to draw the velocity time graph, it will be something like this. It is in the positive direction. Why? Because the particle is going away from the origin. It is going away from the origin, right? That's why in the positive direction and the velocity is increasing. How you see the velocity increasing? Because the slope is continuously increasing. That's why. All right, so this is the first type of graph. Now, how will an acceleration time graph of it look like? Let's see that. If I want to draw an AT graph of this, since the velocity I told you is linear, that means the acceleration is constant. It is something like this. The velocity is increasing with time. That means acceleration is positive. That's it. Next graph in this category looks something, let's say, two things which you need to know whenever an ST graph is given. First thing is the direction, where the particle is traveling, whether positive or negative. And what about the velocity, magnitude, whether it is increasing or decreasing. Okay. So let us see that in this case, this red graph which I have drawn now. First of all, see the tangent. Initially, you can see the tangent is parallel to the x-axis. And finally, you can see it is basically becoming almost perpendicular. That means if the slope is parallel, that means what is the velocity over here? It is 0. Because if the slope is parallel, that means what? If the slope is parallel to the x-axis, the value of the slope is 0. That means the velocity is 0 over here. And at the bottommost point, you can see that the slope is almost perpendicular. That is, it is a very high value over here. Not exactly perpendicular, but it's almost like that. So that means from some value of 0, it is getting some value. There is some velocity over here at this point. That means definitely the velocity is increasing. The magnitude is increasing. But what is the direction? Where is the particle going? The particle was initially at some x. It came back down at x equals to 0. At this point over here, what is it? This s equals to 0. That is, it traveled in the negative direction. So the particle is traveling in the negative direction. So the velocity time graph has to be in this region. Okay, within this region, the velocity time graph have to be in this. And its velocity is increasing. So that means what? The velocity time graph will look like this. And how will an AT graph look like for this? Now we have the negative direction, increasing velocity. That means the AT graph will be like this. In the negative direction as well. Clear? Next category, in this, if suppose the graph looks like this. Now see the magnitude. Magnitude, how will you see? By the slope. Initially, the slope is almost like this. Finally, it becoming parallel to the x-axis. That means the final velocity is what? 0. Initially, it has some velocity. Finally, over here, it is becoming out to be 0. But here, there is some velocity. So that means what? The velocity is decreasing with time. Clear about that? What direction? Particle, you can see it is going away from the origin. In the positive direction, the velocity is decreasing. That means the graph of it will look like this. And how will the AT graph look like? Now it is in the positive direction. AT graph will be this, in the negative side basically. Alright, because it is in the positive direction, velocity decreasing, acceleration will be minus a only. I told you when we were discussing acceleration, deceleration, this thing, right? So this is the idea over here. Now the last category, initially, let's say the velocity, there is some 10 slope over there. Finally, it is becoming parallel. That means what? It is the velocity magnitude is decreasing for sure. What is the direction? Again, in negative direction. So the graph of it will look like this now. And 80 graph will be this, the brown one. Because velocity is decreasing and in the negative direction. So you can think of it like that, negative, negative becoming positive. That's why the graph of 80 is basically in the positive direction like this. So hope I have made all the graphs clear. Please do try them by yourself and check whether you can get them or not. Okay, this was basically about the graphs. Few more important points I want to write it over here. I have also already mentioned that previously is that the area under VT graphs gives what? The displacement. This point I already told. The second point is that the area under AT graph gives what? Change in velocity. Change in velocity. I didn't told you this point. This is also very, very important. Area under the AT graphs gives us change in velocity. This was it. And obviously slopes. The slope of the ST graph or XT graph gives the velocity. Slope of VT graph is the acceleration. Clear? Let me give you one question based on this. Suppose you are given now an AT graph. It is acceleration in meter per second square. Time is in seconds. And it looks like this. Initially it's going up, then it's going down. First of all, the first thing which should know is that acceleration is not constant. Means implies cannot apply equation of motion. That is the first important point in this. Now, how to solve these type of questions? If suppose it is given that the question is this value is suppose let's say 4, this value is let's say suppose 2, and this is 4, and this is 0. If the question goes like that, initial velocity of particle is 2 meter per second, find the final velocity. How will you solve such type of questions? I told you area under the AT graph is what? The change in velocity. So what is this area? The area is basically a triangle. Base, which is 4, height is 4. So it is what? 8 meter per second. Clear? Okay, that is basically the area. Area gives us change in velocity. So 8 is equals to delta V. Delta V is what? V final minus V initial. Now what is V final? You want to find out what is V initial? It is 2. So V final becomes now 10 meter per second. That is how we have to proceed for this. Alright, so for such type of questions where the acceleration is not constant and it is given in form of graph, we will be using the area concept to solve such questions. Don't apply equations of motions to solve. Alright, so hope I have made this clear to you now. So that's it for today. In the next session, we will be discussing the projectile motion questions. Okay, what is a projectile motion and what are different kind of questions can be framed from that. So that's it for today. So lastly, again, please do check the Prepaze site, book a free trial. Hope you enjoy your teaching. So we'll meet in the next class. Okay, thank you.